Welcome viewers to Gateway Learning Center. Today we have a question on geometric progression which came in 2022, internal paper 2. So given that the third term and the sixth term of GP 3 over 4 and 3 over 32, find the first term and the common ratio. Then 2, find the nth term. Then the last one, find the sum to infinity of the progression. So the first thing here, we need to understand the formula of Tn is equal to ar to the power n minus 1. So this is the formula which goes with GP, geometric progression. Now in the question, they are saying, given that the third term and the sixth, so the third term and the sixth term of GP are this one. So the third term will go the first part because these are moving respectively. So this and this will match. So I say third term has 3 over 4 and the sixth term as 3 over 32. So this is how we can simplify the equation. Now let us use these values and plug them in the formula. So we have Tn has been already given, which is this part. So we'll say now AR, where there is n, we'll put the third term. So we'll put 3 minus 1 is equivalent to 3 over 4. So this is the first part of our equation. So if you simplify, if I want this part can be here, there's no problem. So to simplify now, we have r and 3 minus 1 will get 2, which is equal to 3 over 4. So this is our first equation we can make. Then the second equation, we're going to get this one now. So r, where there is n, we'll put now 6 minus 1, which is equivalent to 3 over 32. So if you simplify, you find that you're going to get AR 5 is equal to 3 over 32. So this is our second equation. So we have this first equation, and then we also have this second equation, then we also have the first equation. Now after you reach at this stage, the next thing to do is to now use the formula which we use whenever we are finding the common ratio. We know that we have term number 2 minus term number 1. So this is the one we're going to use for us to find what we are looking for. So now from here, we have the second equation, which is here. Then from there, let me set my camera. Okay, so we'll get now AR to the power 5 is equal to 3 over 32. Then we divide now by the first one, which is AR to the power 2, which is equal to 3 over 4. So now you combine the law of indices here, so we can cancel first what is common. So A and A, these two are common, so we cancel them. Then we know that R to the power 5 and r to the power 2, these two have the common base. So when we divide according to the law of indices, it's like we have r to the power 5 over r to the power 2, which can be also written or worked out as 3 r to the power 5, then since the bases are common, minus 2, so r to the power 3. That is how it can be simplified. So will remain now, so 5 minus 2, it will give us now r to the power 3 is equal to, then this part. How can we deal with this part? So for us to deal with this part, this is division. We know that if we have 3 over 32, this division will come into multiplication. Then this will go up, so it will be 4 over 3, like that. Then from here we can cancel 3, so r to the power 3 is equal to, so we have 1 by 4, it will give us 4 over 32. Then from here, let me use this space. Hope you have seen where you are coming from. So from here we can reduce the numbers. So how can we reduce the numbers? From here, we'll say r to the power 3 is equal to, if you say 2 here, to give you 2, then the half of 32 will give us 16. So you can further reduce now to say r to the power 3 is equal to, let me write here, so r to the power 3 is equal to, so remember we are here, so 2 into 2, it will give us 1 over, then 2 into 16, it will give us 8. So that is last part we can now deal with. So from here we'll say now the cube root and the cube root. So you can cancel 3, So r is equal to the cube root of 1 is 1, then the cube root of 8 is 2. So that is how we find our common ratio. So what we mean by cube root is that which number can we multiply 3 times to get 8? So this is 2. So we have calculated for our common ratio. Then to find the first term, we'll say, okay, we can get one of the equations which we made, this one or this one, depending with your own choice. All the equations will give us the same answers. Then from here, let me pick this one. So I'll pick it from here. As my choice of the equation. Where there is r, I'll put 1 over 2. So I'll say first term, open bracket, 1 over 2, then square is equal to 3 over 4. Then from there, we can now say first term, which is a, then when you square 1, you get 1, then you square 2 again to get 4, then is equal to 3 over 4. For me to remain with a alone, I can do two things. Either I can divide 1 over 4 here and here, or I can do the reciprocal, where I will say 1 over 4 over 1, then this a I have 1 over 4. Then what I've done this side, I should also do the other way. So now I will get is equal to 3 over 4. Let me remove this part. 3 over 4. Then what I did here should come this side. So 4 over 1. So this 4 and this 4 will cancel. This 1 and this 1 will cancel. Then I'll remain with A as my common, my first term. So A is equal to, then I can successfully say this 4 and this 4 can cancel. So here will remain with 1, here will remain with 1. 1 by 3, I'll remain with 3 over 1 by 1, it's 1. So A is equal to this into this, I'm going to get a 3. So that is how we calculate the value of R and the value of A, which is the first term. So the first part of the question is done. Now, next we'll talk about the second part. So the nth term. Now we can find the nth term in this way. Okay. So nth term, we're going to bring the same concept to say Tn is equal to AR n minus 1. So nth term, we'll say Tn is equal to, while this A, we'll put 3, which we calculated. Then while this R, we'll put 1 over 2. Then n, we don't know, minus 1. So we can simplify here to say the half of 3, it will give us 1.5 n minus 1 or 0.5. Or if we want, we can say 3 by 1 to give us 3 over 2, then n minus 1. So this is our nth term, or we can reduce these numbers to remain with 1.5, then n minus 1. So or you can get 1.5, then n minus 1. It's one and the same thing. If you want, you can put 0.5. So that is how we calculate for the nth term. Then the last part, talking about the sum to infinity. So the sum to infinity will be calculated as this. In the question paper, they even give the formula for the sum to infinity, which is S to infinity is equal to the first term over 1 minus R. So we know that when R is less than 1, now we know that the first term was 3 over 1 minus our common ratio is 1 over 2. And from here, we'll say 3, 1 over 2, 1 over 2. So 1 minus 0.5. We're getting still 0.5. So we remain with 1 over 2 like this. So after you subtract there. So how do you do this one? So it is this 3 times this 2 times 3 over 1. So it will give us 6 over 1, which is equal to 6. So this is our answer. So what I've done here is that I have 3 here, division, then 1 over 2, then 3 times, I change this into multiplication, times, then this will interchange, so 2 over 1, therefore 3 by this one, we get 6 over 1, 6 into 1 into 6, it will give us 6. This is how I came up with that answer. So this is the question which came in 2022 internal mathematics. So that is how we do the calculations. That is how we do the calculations. So say here we had 6, so on over here we get 6. So basically this is how it is done. So it's just a simple thing of calculations. Thank you for watching. We'll post another video which will have a different type of question but under the same geometric progression. Remember to subscribe to our YouTube channel for more videos with good content.